working on the safe software on Matte Foundation. First, go to File and select New Model. After that, design code. Set the IS code as 456 and design preference. Go to design minimum cover as 50. Bottom and top cover as 50. Here code IS456. Okay, click on OK. Then confirm here unit should be metric. Okay, click on grid lines. We have total width of 18 in X and in Y direction, so we will select 19 grid and 18 X in 19 and 19, and the spacing will be, will take spacing 2 on 1. Click on OK. The grids will be formed here, and we will be drawing the matte now. Matte function. Before that, we will be defining the materials. Go to define materials. We will be defining 40 grade concrete and material type as concrete, and we will be inputting these values as per the standard values. Define and now, after defining the materials, we will assign to the single elements. The materials will assign the materials to the elements. Now, slab properties, add new property. Slab material as M40, and select the thickness as, keep the thickness of the slab as 500. We'll select the type as matte foundation, matte. Okay. Now we'll define the column properties and new property. We have two types of column, two different types. It's 500 to 500. So click on OK and add a new material, column which is a 600 mm material. After that, OK. Now go to define and subgrid, add property, and subgrid modulus compression. Then we calculate it is 3 into 10 to minus power 4, and OK. And now we have defined all the things. Now go to define and check the load patterns and case, and we will add a new load combinations here, that is for service and ultimate load patterns. Then okay, case and okay. Now go to load combination, add a new kingdom. And it is defined. Now all the elements are defined. Now we will draw the slab. Now go to draw slab areas, select the property which we have defined, that is slab, and now click on the grid and according to the dimensions of our thing, our slab, we will click on the beginning point to close the section. Okay. After that, click on cancel, click escape after that, and set the mat foundation in the slab area which are drawn. Confirm here, one area 4 edges, and now we will be extending it by 2 meters on each side. So select it and go to edit menu, edit areas, and expand shrink areas. We will be expanding it to 2 meters, that is in 2000 in mm, 2000. Okay, now we can see that our mat foundation area is offset by 2 meters. On the other side, all sides. Now go to draw menu and we'll be drawing the columns. Go draw and draw column property below as none and property above as 500 height below as 0 and height above as 2 or something you can do. Then place your first column here and grids will guide us to place the columns. Now we have drawn all the columns of 500 mm into 500 mm of dimensions. After that, click on escape and it will go. Now we will be drawing the columns of 600 mm to 6. So go to draw menu, draw column, and now change the property above as 600 and place them here. Click on escape. Now the columns of both the dimensions are drawn in the slab area, as you can see. Now we will be drawing the design strip. Go to draw and draw design strip, strip A, and change the width as 4 meters. Now draw them along the x-axis through the center of the column. After drawing every time, click on outside. go to draw menu, we will be drawing a design strip. Go to draw design strips, and 4 meter into 4 meter, change the width is 4 meter, and we will be drawing this through the center of the column. Now as I draw the design strips in the x direction, as the same we will draw in the y direction. Go to draw design strips. Now change the strip layer from here A to B, and we will be drawing 4 strip layers in the y direction also. The grid is assisting us. Now we will be assigning the properties to the foundation. Click on the foundation, conform here on the left corner, and go to assign support data and soil property. Select the soil which we have defined, soil. Click on OK. The soil is defined now. After assigning the soil property beneath the foundation, now we will assign the live and dead load to all the columns separately. Then click on the column, go to assign load data, point loads, and select dead load, and the dead load is 1850. This column is of dimensions 500 into 500 mm. So click on OK. Next, please select and go to assign load data, point load, change the dead to live, and the live load is 797.6. dimensions is same. So we will follow this procedure throughout the columns, whole columns present in our mat foundation, and we will assign the different loadings present on each column. Now we will assign the rebar material to the mat and stripe. Okay, right click on the mat, go to design, change the rebar material to HYST 500 as we have defined. Click on OK, and now we will also define we will define for stripe. Okay, 4 on the y-axis and 4 on the x-axis. Okay, we will do it. After that, we will run analysis. Go to run analysis, and we have saved it, and we can see the displacement values of the at different regions. You can see. Now go to run analysis and design. Then go to display menu, show shear punching ratio, and as you can see that the shear punching ratio is not less than 1. It should be less than 1 punching. So let's go unlock the model, and we will increase the thickness of the slab. Go to define slab properties, modify show property, and we will increase the thickness by 900 mm, and let's check it. Now run analysis and design. After that, show punching ratio. As you can see, the punching ratios of still 4 columns. Here 4 columns is not less than 1. So we will increase the thickness again. Unlock the model, go to define slab properties, modify, and we'll increase the thickness by 1200 now. Okay, run analysis and design. Show punching ratios. As you can see, the punching shear of all the columns is less than 1. Hence this is the final design of the column under which the design which check is all the members. So extrude view, click on extrude view, okay, and click on 3D. This is the 3D model of our mat foundation as we have designed, and click on okay, go to plan, okay, go to design menu, go to display and show slab design, click on the impose layer A, okay. As you can see the top and bottom layer intensity of the concrete, see, and strip process we can choose a dead live, and you can see the dead. Okay. Go to display and show slab slash forces. Click on the display menu and show slab stresses, slab forces. Click on load combination, select load compression, and click on the corresponding component to view the corresponding result. We will click on the maximum momentum and okay. It is the maximum momentum. As you can see, it is the maximum momentum. You can see. Similarly, you can view other results also. Now go to display menu and show crack widths. These are the width cracks at the bottom face of a slab, you can see, and each of the crack should have different width, as you can see here. And if you want to see the cracks on the top face of the footing, click on the slab on top faces and you can see the crack width on the top surface of the slab. The crack width is the different color combination have the different values. It is e power v, which is raised to the 10 to power minus 3, and which is quite negligible. Now go to the run and run detailing. As you can see, after detailing, our components are visible to us. This is the slab rebar middle strip and slab views. Go to it is the plan of our slab. It is the bar table. It is the basic plan of our slab. It is the rebar plan. It is the top rebar. It is the reinforcement profile. It is show that the distribution along the layer 1, which is x-axis, and it is layer y-axis. You can see. And these are the drawings, elevations. is of the bed. You can see our slab thickness is 1200 mm. You can see here, and it's all done. Thank you for watching.